afternoon, ladies and gentlemen. We are all welcome to today's class. Today we'll be talking about the divergence, the core, and if time permits us, we'll move to vector integration. So at that point, for the vector integration, that one will help us to be able to talk about further application in this particular course. So my name is Dr. Shegun Oke. Thank you for listening. Can you all see my screen, please?
Okay. Yes, sir.
Thank you. So the divergence. Let's look at the divergence. The divergence. We talked about the formula of divergence the other time, how we use the del to multiply everything we have. So let's look at the example. Number one example said, if A is equals to x squared z I minus 2y cubed z2j plus xy squared zk. If x squared, if A equals to this, the question says find del of A or div A. Where you see these, they're talking about divergent at the point 1, -1. Well, this is we use this one as a boundary condition at a point whereby you use it to substitute into your x, to your y, and so on. So let's look at the solution of this. The solution says dev A is equals to, we know the dev there of definition, it says d dx I plus d dy j plus d dz k dot s squared zi minus 2y cubed z squared j plus sy squared z k. So remember component by component. Let I go to I, let j goes to j, let k goes to k. So we have it to be d dx of the entire I component be I s squared z. Remember I dot I will be 1, so you don't need to put I again. Plus d dy of minus 2y cubed z squared plus d dz of xy squared z. Now, in this case, what do? We can differentiate this one with respect to x. You have 2xz. Do you agree with me? So here, we have negative here. It will affect this. with respect to y, it will be 6y squared z squared. Then plus z. When you differentiate z here, you have 1. 1 multiplied by xy squared. Xy squared. That's the solution. But at what? At 1, negative 1, 1. So at what? Anywhere you see x, this is your x, this is your y, this is your z. That's the meaning. So you have 2 into 1 multiplied by 1 minus 6 into negative 1 squared. 1 plus 1 into negative 1 squared. So which will be 2 multiplied by this, 2. It will not be plus because it's minus. This will be plus, right? Making 6 plus 1, which is equals to what? Negative 3. That is the solution. Any question? Any question, please? Silence means no question, right? Okay, let's move on. But we can also have, let's look at number 2 says, given a phi equals to 2s cubed y squared z4. Now said find a. Del dot del phi or dev grad phi. B. Show that del dot del phi is equals to dev squared phi. Where dev square equivalent to d square, I gave you this definition initially, plus the square, the y squared, plus the square, the z squared. Denote the Laplacian of the word Laplace, Laplacian operators. So if we look at the A, let's solve it. The solution will be A. So let's look at it. Here says we should calculate, look at this. It says we should calculate this multiplied by this, dot this. So meaning you need to first of all resolve del phi before you multiply, before this. Not that you just put del and del phi at the same time. Solve them one after the other so that you can have a good solution. So let's first of all solve this one. Del multiplied by this, they are together, right? So it is easier for us to do that. All we need to do is I d dx of our file. Our file is 2s cubed y squared z4 plus j 2s cubed y squared z4 plus k 2s cubed y squared z4 equals to. Now let's differentiate this with respect to x, the first one. Remember, this is just there multiplied by phi. Our phi does not have any components. It's just a single function. Don't forget. So don't say there will not be high. There will still be high. The component will be from the del that we have. So please take note of that. So in this case now, when you differentiate with respect to x, what do you have? You have 6x squared y squared z4 because they have multiplication between them. Don't forget, I will follow. Plus, differentiate with respect to y, you have 4s cubed yz4 j. Then plus the one of z. 2 multiplied by 4, 8. So you have 8s cubed y squared z3. Okay. So we have this one. This is our this. So if you have this, we can now find the dot of this one. We can find these dots, this. If I want to find this one now, it is simple for me. I know del. The del will be d dxi plus d dy j plus d dz k dot the entire value, which is 6x squared y squared z4i plus 4x squared cubed yz4 k plus 8 s cubed y squared z3k. So all we need to do is component by component. D dx of 6x squared y squared z4 plus d dy of 4s cubed yz4 plus d dz 8s cubed y squared z3 . So all we need to do is to differentiate. Differentiate this with respect to x. You have 12xy squared z4. Differentiate this with respect to y. You have 4s cubed z4. Differentiate it with respect to z plus 2 times 3 times 8 is 24s cubed y squared z squared. So that is what they ask us to do. If you are able to establish it, simply means you are good to go. So we are asked to prove certain things. How do we prove it? B. The B aspect said, show that del dot del phi is equal to del square phi. So it is very simple. What is del? A del is d dxi plus d dyj plus d dzk dot the phi dx I plus the phi dyj plus the phi dzk. So how do we do that? Remember the way we did the other time? Let the component multiply the component, it's still the same thing. We have d dx of the entire year. Put the phi dx plus d dy of the entire y plus d dz of the entire z. So by the time you multiply these, what do we have? We have the square phi over the s squared plus the square phi over the y squared plus the square phi over the z squared. Something is common to them. I can factor the phi out by saying d squared over the x plus d squared over the y plus d squared over the z. Everything multiplied by 5, which is the same thing as del square phi. So I've already proved that. Did you agree with me? I need a response, please.
Yes, sir.
Any question? Remember, this is our del. And at the end of the day, when you use del to multiply this, when you factor the del out multiplication, del multiplied by del will give you this. We know how you only have the square, the x, because this would have cancelled by then. Don't forget there is a square here in each of them. Okay. Let's move on to the third one. The third one, we have the core. Let's talk about the core. Okay, look at this example. If A equals to xz cubed I minus 2x squared yz j plus 2yz4 k. I will strongly advise you, each of the examples we are solving in your own personal space, go through the past question, pick one question and solve it the way we solve it. You will know that you have solution to all those problems. Then find A cross B, del cross A, which is, or call A. You can call it call A. At the point 1, negative 1, 1. 1, negative 1, and 1. So let's look at the solution on this one. The definition for del A is the same thing as d dxi plus d dyj plus d dzk cross, remember it's a cross, x, let me just put the cross here. Because of space, cross x z cube I minus 2x squared yz j plus 2y z4k. So cross means using determinant theorem, which means I will have the matrix I, J, K. So I have d dx here, d dy here, d dz here. So I have the component of I have the component including the sign, and I have the components so don't forget this sign, minus plus or plus minus plus. This will guide us to be able to solve the problem. So if I pick I, let's say I pick I, that's the first row, first column, first row, first column. What is remaining there is d dy minus 2x squared yz. Then we have d dz 2y z4 minus j. For minus j, remember the one I cross here, the I row will paralyze, the I column will also paralyze. So I will release this one to deal with this one. So it's going to be d dy minus 2s squared yz sorry, remember the y is the one it will paralyze. The next one will be d dx xy x z cube. The remaining one will be what? D dz 2y z4. So plus k. Let's say the k also paralyze. We'll release this one. This k will paralyze. It's remaining d dx d dy xz cube minus 2x squared yz So at the end of the day, what do I have? All you need to do is just to do I and cross multiply. I will be, that means this will multiply this one, while this will multiply minus this one. So the first one will be d dy into 2y z4 minus d dy, d dz rather, of negative 2x squared yz. So the next thing is j. For j, we have, let's say, minus j, or some people can put plus there, but if I put minus there now, it will still work. Why am I saying plus is you can interchange it inside, but let's just say j, let's say d dx into 2yz4 minus d dz of xz3. Then plus k d dx of minus 2s squared yz minus d dy of sz3. So how do we solve this one? It simply means let's differentiate everything here, they are I. Differentiate everything here, they are K. They are J and they are K. So let's differentiate everything here now. If you differentiate this, this means differentiate this one with respect to Y, differentiate this one with respect to Z. So if you differentiate with respect to Y, what do we have? We will have a bracket 2z raised to power 4 minus times minus plus. Differentiate with respect to Z, you have 2x squared y. Everything is I. Any question? So I have minus j here. Let's see whether it's still going to be minus. Differentiate with respect to z. Look at this one. If I differentiate this with respect to x, what do you have? You have 0. Minus, differentiate this with respect to z. You have 3xz squared. J. Let me just move the j here. We have j. Plus k. Differentiate this with respect to s. What do we have? We have negative 4x yz. Differentiate with respect to y is 0. So we don't have any other thing there. So at the end of the day, what do we have? So we have, let's write our component again. 2z 4 plus 2x squared y I minus times minus plus 3xz squared j plus times minus minus 4xyz k. So at the end of the day, this is what we have. But we are given a point. At this point, at the point s equals to 1, y equals to -1, z equals to 1. So anywhere you see all these parameter, all these variables, substitute this value there. So we have it to be, the first one would be 2 into 1 raised to power 4 plus 2 into 1 squared minus 1. Everything's I, plus 3 into 1 then you have 1 squared, everything is to j, minus 4 into 1 into -1 into 1. Okay. So let's do this one. This will be 0i plus 3j plus 4k. That is our final answer. Any question? Any question, please? Are we together, please?
Hello, sir.
I'm with you.
0 high. I think it should be 0.
Yeah,
Do we need to show
zero.
it? Hello, sir.
I put it there so that you know that this particular component is 0. If you put 0 high, it's still the same thing. If you don't put 0 there, it's still the same thing.
Okay, thank you, sir.
Any other question, please? Okay. Silence means we are all on the same page. So let's look at the integration, vector integration also. So then that would lead us into different theorems, Green's theorem, Stokes theorem, and so on. Any question before we move on? I believe what we discuss on integral on the differentiation will help us when we get to the line integral. Okay, let's look at on the line integral on the integration. Vector integration. I believe you know vector integration, so I don't need to. I believe you know integration. You've done the calculus before now, and we are still doing the calculus. Because of our time, I'll just go straight to the main problem so that we will be able to cover at least a good number of stuff before we call it a day. Then also we'll also solve some problem when we get to the, okay, let's solve the line integral. Let's start from line integral. So we have vector integration. Vector integration. So ordinary integral of vectors is being defined. Let's say let R of u equals to R of u equals to R1 of u I plus R2 of u j plus R3 of u k. Be a vector depending on a single scalar variable. Variable u. Where R1 of u, comma R2 of u, comma R3 of u are suppose continuous in a specified interval. Then integral of R of u du is equals to I integral of R1 of u du plus j integral of R2 of u du plus k integral of R3 of u du. So it simply means that this is called an indefinite integral of R of u. Then they now said, if there exists, this is the symbol, there exists. Let me write it down. There exists. You have this. Anytime you see this, they're talking about there exists a vector S of u such that R of u is equals to d du of s of u, then integral of r of u du is the same thing as integral of d du of s of u du, which is equals to s of u plus c. You remember, anytime you work on integration, you add arbitrary constants to it. See, where c is your arbitrary constant factor independent of u. And for definite integral, we can have a definite integral. Look at this one, can be integral of a to b. That is, a is lower limit, b is upper limit of r of u du is equals to integral of a to b d du s of u du is going to be, remember we know this to be s of u plus c to be a to b. Arbitrary constants, upper limit minus lower limit. You don't need to substitute anything to c. We treat it as a constant, and anything multiplied by constant is constant. So substitute upper limit, which is b, minus lower limit, which is s of a. So that is what they ask us to do. In this case, we call this one the definite. Definite means you have a limit function, you have a value for your limit integral. But let's look at the line integral. Are we ready, please? Can we proceed?
Yes, sir.
Thank you. For the line integral, we have a certain value. Let's look at it. For line integrals, so we say that for line integral, I will just give us the definitions, or even we've solved, or we have the definition already. Let's say example 1. If a equals to 3x squared plus 6y I minus 14y zj plus 20x z raised to power 2k. Evaluate. You've seen this question before now. The line integral is c of a dr from 0,0,0 to 1,1,1 along x equals to t, y equals to t squared, z equals to t cubed. It said along the following paths. C, along the following path. Along the following path, please take notes. So those paths is the one that I just created. Which is, let's say our A, this is A. Then for B, what's going to happen to our B? So we add the B to B. Just write this one down too. The straight line the straight lines from 0, 0, 0 to 1, 0, 0, then to 1, 1, 0, and then to 1, 1, 1. So let's solve that. Number 2, let's look at this one. Let's look at question 2. And we're going to start from that question 2. Question 2 says, if R U equals to U minus U squared I plus 2U cubed J minus 3K. So find A, integral of R of U du, and B, integral of 1 to 2 R of U du. So let's solve this one first. So for us to solve this, we need integral of, it said integral of R of U du, which is going to be integral of R of U, put all of them here, U minus U squared I plus 2U cubed J minus 3K du. So which is going to be I integral of U minus U squared I du plus J integral of 2U cubed du minus plus k negative 3 du. So if you integrate this one, what do you have? We all remember that when you integrate x, integral of x dx, I'm giving an example, it's going to be x squared over 2 plus c. So if I'm integrating u now, what do I have? I will be what? U squared over 2 minus u raised to power 3 over 3. Everything is, let's say, plus C1, the first constant. Please mute yourself. Plus the one of j, you have 2 raised to power u raised to power 4 over 4. Let's say plus C2 minus or plus k into minus 3u plus C3. Now let's remember that all the x now, all the component, everything is component by component. You have u squared over 2 minus u3 over 3. I. Remember, we have ci here. We are coming back to that. Plus 2 here, 1, 2 here, 2. U raised to power 4 over 2. J. Minus 3 raised to power UK. C1I plus C2J plus C3K. Now, remember I told you constant plus constant will give you constant. Everything here is still C. So the final answer will be U2 over 2 minus U3 over 3 I. You can't add them together because they are not the same. Their power is different. Plus U raised to power 4 over 2 minus 3 UK. Everything plus C. That is your answer. The B aspect of it says, find this. We are given integral of 1 to 2 r of 2 du. It will be, we've done the integration of the same thing. The integration is up here. This is the same integration. Put them down. It will be u squared over 2 minus u3 over 2 over 3 I plus u4 over 2 minus 3 uk plus c, which is 1 to 2. It simply means anywhere upper limit minus lower limit. Let's do the one of upper limit first. Substitute to all round first. So whatever you see you have 4. This is 2 root squared over 2 minus 2 cube over 3 I plus 2 raised to power 4 over 2 minus 3 of 2. This is J. Don't forget, this is K. Everything you have plus C. You may not bother yourself with that, but let's put it minus lower limit. Lower limit means substitute 1 into where you see U. So we have this one. All we need to do is just to find the solution to this. If you do it very well, you have, or except if you want to also expatiate it very well. Let's do it together. Because of our time, we have 4 over 2 minus 8 over 3. Do this one will be your I plus 2 raised to power 4 is what?
16.
16.
16 over 2 J minus 6 K. Our C will have cancelled out because negative will cancel the C out. So you don't need to bother yourself with the C. Or if you still put the C there, it's still the same thing. But if you put, let's just open everything, minus another high. Remember this I now, the negative will go inside. It will be 1 over 2 minus 1 over 2 minus 1 over 3 I. Then minus times this minus 1 over 4, 1 over 2 again, J plus 3. This will be plus 3K. Remember the C has cancelled out. So if you resolve this one very well, let your I goes to I component, let the I be I. Let the I goes to I, J goes to J, then K goes to K. You will arrive at minus 5 over 6I plus 15 over 2J minus 3K. You can see minus 3K already. Minus 6 plus 3 minus 3K. So when you add this and this together, you have this one too. Then you resolve this one, you have this. So component by component. Any question? Any question?
Yes, sir.
Yes, go ahead.
Good afternoon, sir.
Good afternoon.
Actually, I observed in that the components K where you have the minus 3 into bracket 1. The question in that place we have minus 3K. So how come it's giving us plus 3K at the end?
Because of this.
That was optional. Hello, sir.
Because of the one I circled. When you open this big bracket.
Okay. I understand now. Minus open the brackets. Thank you, sir.
Exactly. You distribute the negative. Then everything will turn to negative. Then the one that have negative will turn to positive.
But sir.
Okay.
Sir?
Go ahead.
Yeah, there is a minus in between the 1/2 and 1/3 in the brackets.
That is why I put it in parentheses. I want you to resolve it first, then this negative will not come to place. Resolve what is in the parentheses first. If you resolve this one first,
Okay. Okay.
so if you want to resolve it, say 1/2 minus 1/3 is what? This is 6.
1.
This is
6
what?
that
3
6.
minus what?
But
Right?
1/6.
1/6. So it will be negative 1/6. That's why we put it. If you open it this way, it said minus 1/2 plus this, you are complicating the matter. Resolve what is in the brackets, in the parentheses. So we have this one to be 1/6, right? Then 1/6 will multiply negative, it will now be minus 1/6i. So if you solve this one too, this is what? 6. 3 times 4, 12. This is 2. 2 times this, what do you have? 2 times 8. Nobody is talking again.
16.
So when you add this one together, what do you have? Which is the same thing as negative 2/3. So
Over
you
3.
negative 2/3. Right.
Okay.
So the one with negative 2/3 can now be the one component by component with this one. Let's say, remember this is minus 2. Minus 1/6. Do you agree with me? So what we have for I component will be minus 2/3 minus 1/6. Solve it. This is 6. How many 3's here? 2. 2 times negative this. Minus what?
Minus 4.
Minus 4. 1.
Minus 1. Minus 5/6.
Is it not the same thing we have here?
Yeah.
So that is how you resolve it. Don't just jump the line. Okay, guys. I believe we have gained 1 or 2 things today. So we have number 1 question. We will continue from there the next class. Because this is application and we need to solve it one after the other. Any question, please? Any question?
Hello, hello, sir.
Yes, sir. So you'll be getting some answer very close, but it will be dangerous for you to be able to conclude if you don't have correct answers to the problem. So that's why you have to be careful when you're solving this problem anytime, any day. Today we are able to talk about the divergence and the core, whereby we use the core to get our Laplacian operator, and also we also discuss the line integral to use ourselves into vector integration. Let's try as much as possible, lay your hands on the past question on your book materials and solve as many as possible. So any question for today?